guys, and welcome back to another week in DearPiggy's Java tutorial. So in this video, we're going to be working on recursion, which is a very big topic in Java. So here's my take on recursion. You either understand it completely or you don't understand it at all. So there's no middle for me, in my opinion. So what we're going to do in this first video is I'm going to introduce to you the basic definition of recursion, explain to you what it is, and then a few key concepts and terms, and we're going to try to create our very simple recursion function where we print out numbers in decreasing order. Okay, so that's our goal for this video. Should be pretty easy. Let's go ahead and jump right in. So what is recursion, guys? Recursion is when we have the function call itself. So previously, all of our functions, what we've done in them is we've executed a certain line of code, it goes down the ladder, and at the very end, it promptly stops. Now, what we're going here is in recursion, you might have a series of actions. You go like 1, line 2, line 3, line 4, but then at line 4 you realize you might get called again. So you get called the same function, so you come back up to line 1, line 2, line 3, and line 4. You realize you have to call yourself again, then you repeat over and over and over. So as you can tell, this is similar to something that loops, which means that we have to have a terminating thing, right? We have to have some sort of condition that tells us when to stop. And this is what our base case is. So our base case in recursion is what stops the method from running forever. Because we can't have it run forever. Because if the method does run forever, we'll get an infinite loop, which is going to result in Stack Overflow, which is basically the compiler saying, I can't handle this anymore, you've got to stop. Right? Okay, so a couple things for method recursion is you need to figure out when and where you're going to call your function in itself, and then when your function is going to stop, so what your base case is going to be. So we've understood the definitions now. We're going to go ahead and attempt to write our own function. And so the first thing we're going to do is write a function that prints out every number in a decreasing order. So we give it, say, take in a parameter of x. If x is 5, it should print out 5, 4, 3, 2, 1. Now, the really easy way to do this is to use recursion, right? This is a classic recursion example. So let's go ahead and get started. I have a replet pulled up here, it's empty. Remember, when we create our methods, we create it in the main class, but not in the main function. So static void, I'm not going to use the return keyword. Let's use decreased numbers, and then let's take in a parameter x. So when I call my function, I'm going to pass in a parameter integer x. So the first thing that I want to do here is as soon as I see my integer x, I want to print it out immediately. So I'm going to do system.out.println x because I want to first print it out onto the screen. Then I need to print out the number less than it, right? And so we keep on doing that. However, our base case is when x is equal to 1, because think about it. When x is equal to 1, that is when we want to stop. We don't want to run anymore, because we don't want to get into zeros or negatives, because then things would get a little bit complicated. So here's how I'm going to do it. And we're going to write the code first, run it to make sure it works. Then we're going to come back in and think about it from the compiler's point of view so that we can understand really what's going on. So if x is greater than 1, then we're just going to run the decreased numbers function, except this time for x minus 1. And that's it. I'm done. Okay? So basically what I'm saying here is whatever number you get, first I want you to print that number out immediately. Then if that number is greater than 1, then I want you to rerun this entire function, except this time 1 less than your x. So then it should probably come in and print out the 1 less than the number x. Then it's going to check if that x minus 1 is still greater than 1. And this cycle goes on and on forever until your x is equal to 1, and then it'll stop. So let's first run this to see if it works. And then let's start with 5, not 45, 5. And then we'll think about it from the compiler's perspective. So we're running the code. Aha, we get 5, 4, 3, 2, 1. So everything works perfect. Now let's explain it. So we come into our function, and our x is 5. So the first thing we do is we print out 5. And so that's what this is. We've printed out 5. Then we check, is 5 greater than 1? Yes, I'd say 5 is greater than 1. So what do we do next? We run the function again, except this time for 5 minus 1. So in this case, now x is 4. So the first thing we do is we come and print out 4. So that's what this 4 is for. Then is 4 greater than 1? Yes. Run the function for x is equal to 3. Print out 3. Is 3 greater than 1? Yes. Then run the function for x is equal to 2. Is 2, x is 2. We print out 2. Is 2 greater than 1? Yes. So now this is where you have to be careful. Next part is to run the function for 2 minus 1. So in this case, x would be 1. So when x is 1, the first thing we do is we print out x. So we print out 1. So that's what this last number 1 is for. But then we check the if statement. Is 1 greater than 1? Well, no, right? Because 1 is equal to 1. So since x is not greater than 1, this base case stops our function because this statement is no longer true, which means that our function can stop, right? So this is recursion, right? What we've done is we've done something that executes line by line, then we get to a certain line that uses itself, and then we have to start all over. So we keep on going in a circle until some base case has been reached. Okay, so let's try an example of what would happen if you don't have a proper base case. So we're going decreasing. When we decrease, we finally get to a point where this condition is no longer true. Now, if we were to do x plus 1, this would mean that this would probably forever be true, right? You would never get to a point where x is no longer greater than 1, assuming that you start off with x being something greater than 1. But this would mean that it would never stop, right? So if we started from, let's just say 3, we'll run our code, and it's going to run and run and run. Now, Replit isn't going to show you this process, but look, guys, did you guys see that? We basically printed out a whole bunch of numbers. At the very beginning, it was really fast, so you couldn't quite catch it. But when you run your code, it goes on and on and on really, really quickly, and don't miss it. See, these numbers are getting printed out, and then it gives you an error. So this is a classic example of Stack Overflow, because your base case is not valid. You didn't give it a proper stopping point in your recursion. So you don't want this long error message. I'm sure nobody wants to read this. So yeah, guys, that was recursion when you make the function call itself. Recursion takes some practice, and it takes some real thinking. So once you finish watching this video, shut the computer. Or not the computer, close the tab out for the video, try to write this yourself, and think about it from the compiler's point of view, and I think you'll understand it then. Our next video is going to be doing an activity for recursion, and so we're going to be doing another classic example of recursion, except this time a little bit more complicated, and we're going to be doing a factorial example. So I'll see you in that video. Bye, guys.